Welcome to Biomedical Engineers TV. We have covered classification of patient monitors and their measurement parameters in our last video. Let's discuss about parameters in simplified details. Let's begin with ECG measurements. The recording of the electrical activity associated with the functioning of the heart is known as electrocardiogram. ECG is a quasi-periodical, rhythmically repeating signal synchronized by the function of the heart, which acts as a generator of bioelectric events. This generated signal can be described by means of a simple electric dipole, pole consisting of a positive and negative pair of charge. ECG signals can be recorded by 3-lead ECG cables, 5-lead ECG cables, or 10-lead ECG cables. You can also measure heart rate and respiration rate along with it. The next measurement related to ECG leads are respiration rate. This is an indirect technique for the measurement of respiration rate. Using externally applied electrodes on the thorax, the impedance pneumograph measures rate through the relationship between respiratory depth and thoracic impedance change. The technique avoids encumbering the subject with masks, tubes, flow meters or spirometers, does not impede respiration, and has minimal effect on the psychological state of the subject. Impedance method for measuring respiration rate consists in passing a high-frequency current through the appropriately placed electrodes on the surface of the body and detecting the modulated signal. The signal is modulated by changes in body impedance accompanying the respiratory cycle. The next parameter is SpO2. SpO2, also known as oxygen saturation, is a measure of the amount of oxygen-carrying hemoglobin in the blood relative to the amount of hemoglobin not carrying oxygen. The body needs there to be a certain level of oxygen in the blood, or it will not function as efficiently. A blood oxygen monitor displays the percentage of blood that is loaded with oxygen. More specifically, it measures what percentage of hemoglobin, the protein in blood that carries oxygen, is loaded. Acceptable normal ranges for patients without pulmonary pathology are from 95 to 99%. For a patient breathing room air at or near sea level, an estimate of arterial PO2 can be made from the blood oxygen monitor. Saturation of peripheral oxygen, SpO2 reading. Let's know about NIBP. Most of the patient monitoring systems are based on the oscillometric measuring principle. A number of automated blood pressure measuring instruments have been designed which make use of the Riva-Rocci method. This technique was introduced by Riva-Rocci for the determination of systolic and diastolic pressures. Initially, the pressure in the cuff is raised to a level well above the systolic pressure, so that the blood flow is completely terminated. Pressure in the cuff is then released at a particular rate. When it reaches a level which is below the systolic pressure, a brief flow occurs. If the cuff pressure is allowed to fall further, just below the diastolic pressure value, the flow becomes normal and uninterrupted. The measurement consists of systolic, diastolic, and mean pressure. Let's move towards temperatures measurements. The transducer, normally used for temperature measurement in a patient monitoring system, is a thermistor. Changes in resistance of the thermistor with changes in temperature are measured in a bridge circuit and indicated on a calibrated meter. The measuring range is 30 to 42 degrees Celsius. In a patient monitoring system, provision for 2-channel temperature measurements are usually made. The temperature probes are skin, rectal, esophagus, and delta temperature measurements. In the next video, we will cover up IBP, ETCO2, cardiac output, EEG, and BIS measurements. Keep watching Biomedical Engineers TV. See you guys in the next video.